Hey guys, it's Danny here from Disrupt Tutoring, and as always, it is a pleasure to join you. In this video, we're going to do a question from the November 2019 Grade 12 Physical Sciences Paper 2. This question deals with the autoionization of water inside a standard solution of a hypothetical strong base called Z hydroxide. Questions 5.1 to 5.3 are covered in a separate video, and the answers are not relevant to the ones dealt with here. We're given the balanced chemical equation for the autoionization of water, as well as the ionization constant of water at a temperature of 30 degrees Celsius. The first question asks us to classify the autoionization of water as an exothermic or an endothermic process. To answer this question, you need to recall the value of the ionization constant of water at 25 degrees Celsius. We know that we have an increase in temperature from 25 degrees Celsius to 30 degrees Celsius, and the value of the ionization constant also increases. For an increase in the ionization constant, we need an increase in the concentration of the products of this reaction. We also know that an increase in temperature always favors the endothermic reaction, since endothermic reactions take in energy. So since we have an increase in products and the forward reaction is favored by an increase in temperature, meaning that the autoionization of water is an endothermic process. The next question asks us to calculate the concentration of hydronium ions in the Z hydroxide solution at a temperature of 30 degrees Celsius. Since the Z hydroxide is in solution, we know that there is water present, and this water slightly ionizes according to the balanced chemical equation given here. We can use the ionization constant of water at 30 degrees Celsius to determine the concentration of hydronium ions in the solution at that temperature. We know that the ionization constant is equal to the concentration of the products over the concentration of the reactants. For water, this just happens to be the concentration of the hydronium ions multiplied by the concentration of the hydroxide ions. And we know that this number at 30 degrees Celsius is equal to 1.44 times 10 to the minus 14. So we can get the concentration of the hydroxide ions from the concentration of the Z hydroxide solution at 30 degrees Celsius. In this case, we can substitute these values in, and we can find that the concentration of the hydronium ions is equal to 6 times 10 to the minus 14 moles per dm cubed. And this is what we expect because the power of 10 to the minus 14 tells us that the pH of the solution is 14, which is the pH of a strong base. Before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.